I made a generator that is powered using a DC motor and a 3.7 volt battery, and it charged some of my devices and a phone. In previous videos, I've explained that when a magnet passes a coil of wire or a coil of wire passes a magnet, current is induced inside the coil and electricity is created in the process. And with that in mind, we can also understand that there is some kind of motion. Today, we're going to look at rotational movement, and one of the easiest ways to achieve that using a DC motor. This is a DC motor from an electric cordless drill, and this is a gear from an angle grinder. I need to join them together, but the motor shaft is too small while the inner diameter of the gear is too big. So I got a strip of tape, dropped super glue on the shaft of the motor and wrapped the tape around the shaft. Adding more super glue as I go to avoid the shaft slipping inside the tape. I then added some more layers, but with hard paper to match the inner diameter of the gear, and I pushed the motor shaft into the hole of the gear tightly and put some super glue around all of it and reattached the gear to the motor shaft.
I know you told your friend you're not okay, and tell me what's wrong and why you never said you felt that way. Guess you're trying to stay strong and fake a smile until I look away, but I've known you too long.
This is a generator that I put together a while back, and I've been using it ever since because it gave me up to 50 volts at 3000 RPM. Therefore, even at lower speeds, the generator can give out useful voltage. Go check out the video where I made it on the channel. I repeated the same thing I did with the motor shaft. I wrapped a long paper strip around the shaft of this generator, and around it I put a small gear. I bet you already know how this is going to be. With the larger gear as the driver, the smaller gear on the generator will spin at 3 times the speed of the driver gear connected to the motor. To put the whole thing together, I got a large piece of wood for the base and placed the generator where it needs to be, applied super glue on the base and also under the generator, and then pressed it on the board for a solid bond. I then got pieces of pre-cut flat PVCs and glued them to the body of the DC motor to act as a raised support for the motor to also match the height of the shaft of the generator. It took me a while to put the whole thing together, but I eventually did it. And then I placed it on the board and secured it with super glue.
Look away, but I've known you too long. It hurts to watch your blue eyes fade to gray as you fade away. As you fade away. As you fade away.
It was a bit stiff, even while turning it with my hand, but just to be sure, I connected the battery to the motor, and though it spins, it does so with a lot of resistance, and I know that when a load is added to it, it will stall for sure. But hoping that would not be the case, I got a multimeter and connected its terminals to the generator, set the multimeter to 20 volts on the meter dial, and connected its battery.
Look away, but I've known you too long. It hurts to watch your blue eyes fade to gray.
And just like I suspected, the gears mesh too tightly and therefore doesn't give off much voltage, and such resistance made the battery to burn my fingers a little bit. So I tried pushing the gears on the motor back a bit, and it seemed to loosen up a bit. So I tried again, and now it easily passed the 20 volt mark on the multimeter. I changed it from 20 volts to 200 to see what we're actually getting, and it quickly got up to a steady 30 plus volts, which is quite impressive since the input power is just 3.7 volts, because there is no such thing as free energy. All those videos you see out there are fake. On the second attempt, it dropped to 28 volts, and I'm guessing that's because the battery has been drained a bit from the first try, and during the test the voltage kept on dropping. By the way, if you love videos and experiments like this, explaining systems and how they work, please don't forget to like and subscribe. Then I got this LED that works both with AC and DC voltage. Connected the terminals of both LED and the generator together and the battery to the terminals of the motor, but the gear mesh was too tight yet again, and the load also added a resistance. So to ease things a bit, I poured oil on the generator bearings, or rather where the shafts passed through the PVC mount to help with movements, and also poured some on the gears and spinned it to circulate the oil around the rest of the gears. And beyond my expectation, that caused a messy situation. Reconnecting the LED, it lights up now, and the camera plus the bright outdoors did not let the LED shine very well. So I changed it to a bigger one, thinking that maybe we will see it better and brighter, and still didn't help. But that was not a waste. At least you can see that the generator could do some work. So I moved over to more important things, which is to know if the generator can do more useful work. This is a buck converter. It turns DC voltage into a steady output of 5 volts for the liberty of charging different things that require a USB and 5 volts to charge. I connected the generator leads to the input terminals of the buck converter, connected the battery to the motor, and the buck converter comes on. You will know when the buck converter is on when the red light comes on. Now, what voltage are we actually getting out of this? I already know what voltage we are getting, but I just wanted to be sure. So I connected a multimeter using a USB wire. The buck converter gives off a steady 5.2 voltage out of the input voltage of over 25 volts. And one fascinating thing I noticed is that when power is cut from the buck converter, it doesn't go from 5 volts to 0 flat. Rather, it goes down slowly. It reduces from 5 to 4 to 2, 1, and then 0. It helps to save your electronics from instant voltage drop. So I got back the LEDs and connected them to the circuit, but to my surprise, the buck converter pulsates and doesn't stay on steadily, making the LEDs to flash. I don't know the cause of this. If you do, let me know down in the comments. But let's move on. I got a Type-C USB cord and a rechargeable lantern. Power the generator, and the circuit charges the battery.
Smile until I look away, but I've known you too long, it hurts to.
You will notice that because of the slow voltage drop we saw earlier, the lantern still charges for a few milliseconds before stopping. So the circuit discharges slowly, giving the lantern the effect of a UPS to avoid damaging the charging circuit of the lantern. Still impressive if you ask me.
But I've known you too long, it hurts to watch your blue eyes fade to gray as you fade away, as you fade away.
Yeah, I'm about to fade away, cause every time I wake up I feel like it's Monday. Something's going wrong with all the chemicals up in my brain. All of a sudden
I got a small phone, and this generator also charged it without breaking a sweat.
convenient, okay. Just let me be me and I'll stay out of your way. I can see the way you look at me, I'm such a disgrace. I never really asked to be brought into this place. You wanna love me? Well then baby, have a taste. All the highs and the lows, no you'll never be the same.
You will also notice that when the buck converter turns on and loads the generator, there is a change in speed and reduction in sound. The load resistance makes the generator to slow down. Talk about practicality. Anyways, that's it for today's video, where we talked about one of the ways to create movement in a generator to create electricity, because without movement or motion, current will not be induced in the wire and therefore electricity will not be generated. That's it for today. If you like videos like this talking about different engineering systems and how they work, consider leaving a like and also subscribe. Thanks a ton for watching. I'm Emmanuel and this is Nexel Labs.